by ds. What is breakaway point? What is breakaway point? First, let us see what is breakaway point. Sometimes here one pole, another pole here, both are starting points. If we select any point after this, even number, that's why it is not any point after this, it is not part of root locus. But if we select any point between these two poles, it is part of root locus. Therefore, root locus coming from this pole in this way, from this pole this way, both are meeting at one point. Both are meeting at one point. Then they are breaking away, and this goes to infinity, and this goes to infinity. A second order system. So, this point is called breakaway point. Breakaway point. This point is called breakaway point. How to find that breakaway point? They are approaching each other, but at what point they are breaking away? At what point they are breaking away, we do not know. That can be found by using dk by ds. Dk by ds. What is the characteristic equation? 1 plus g of s h of s equal to 0. That is characteristic equation. G of s h of s can be written as 1 plus k times n of s upon d of s. We can write of s upon d of s. Suppose this characteristic equation is equal to 1 plus g of s h of s equal to s plus say mn b, s plus b to the power r multiplied by x of s. The polynomial, characteristic polynomial is written like that. It means what? What is the meaning of this? It has repeated poles. It has repeated poles at r points. It has r repeated poles. It has r repeated poles. The remaining polynomial is x of s. Remaining polynomial is x of s. Suppose if it is nth order degree, means the degree of x of s is n minus r. Because r is we have taken separately. It has repeated roots. What is the breakaway point? It has two roots at the same point. Two roots at the same point. It means repeated roots. Breakaway point means repeated roots. So the repeated roots at B, repeated are repeated roots. How many? R repeated roots at B. R repeated roots at B. R repeated roots at B. This polynomial has, this characteristic polynomial has R repeated roots. Suppose I am differentiating this with respect to s. What you will get? D, let us call this as P of s. Characteristic polynomial can be called as P of s. dP of s upon ds equal to, if you differentiate this, what you will get? R multiplied by s plus b to the power r minus 1. If you differentiate this, you will get 1 plus multiplied by x of s. If you differentiate the characteristic polynomial, you are getting this. Is it true? Is it 0 for s equal to minus b? Where the repeated roots? The repeated roots are at minus b. Repeated roots are minus b. So characteristic polynomial must be 0 for minus b. If you substitute minus b there, because it has repeated roots at minus b, that's why it becomes 0. The characteristic polynomial becomes 0. The characteristic polynomial becomes 0 this becomes 0 equal to 0 at s equal to minus b, because at minus b it has r repeated roots. You check dp by ds, that is also equal to 0 if s equal to minus b. You check, if you substitute minus b, this becomes 0. This becomes 0. If you substitute s equal to minus b, this also becomes 0. So the entire equation becomes 0. So if characteristic polynomial is 0 for minus b, means its derivative also 0 for minus b. That's why we can find the derivative of that characteristic polynomial and equate to 0 to find the repeated roots. Let us differentiate this. What is the characteristic polynomial? This is the characteristic polynomial. If we differentiate that, what is dp of s? The characteristic polynomial by ds equal to, if we differentiate this, 1 becomes 0 plus, what is that? d of s square, d of s multiplied by k times n of s n dash of s minus k n of s d dash of s. Can I write like that? S equal to minus b. Or I can say that d of s k d of s n dash of s minus k can be taken outside. D of s minus n of s, n dash of s minus n dash of s, d of s n dash of s. Okay, n of s multiplied by d dash of s equal to 0, because denominator can become 0. If you bring this to right hand side, it becomes 0. Therefore, numerator equal to 0. So, to find repeated roots, we have to find d of s multiplied by n dash of s minus n of s multiplied by d dash of s equal to 0. If you equate that, you will get repeated roots. To find repeated roots, what we have to do is, we have to find d of s multiplied by n dash of s minus n of s multiplied by d dash of s equal to 0. K is not equal to 0. Therefore, this is the condition. This is the condition to find repeated roots, because repeated roots are roots of dp by ds. dp by ds. So the same condition can be obtained by dk by ds also. What is k? 1 plus k n of s upon d of s equal to 0 means, what is k? K n of s by d of s equal to minus 1, or n of s by d of s equal to minus 1 by k. Or this implies k equal to minus d of s upon n of s. Am I correct or not? K can be found. Therefore, dk by ds equal to dk by ds equal to, what is dk by ds? dk by ds equal to dk by ds equal to n of s square, n of s d dash of s, d dash of s is in the numerator, minus d of s n dash of s. One minus sign is there. That is equal to 0. Or we can say that n of s d of s, d dash of s plus d of s n dash of s equal to 0. Or you can write d of s n of s n dash of s plus minus n of s d dash of s equal to 0. We got the same. 1 and 2 are same. So even if you find dp by ds or dk by ds, both are same, gives the same result. Therefore, to find the repeated roots, we can find dk by ds and equal to 0. Therefore, dk by ds equal to 0 will give repeated roots. So now we have 6 rules. This sum is sufficient to solve 6 rules. Another two rules we'll see later. So what is the root locus? For that we have to find the roots. N equal to what? N equal to 3. M equal to what? 1. So 3 root locus branches. One will end at 0. The remaining 2 will end at infinity. The remaining 2 will end at infinity. So 2 end at infinity. 2 end at infinity. 1 will end at 0. What are the poles? Poles are -2, -3, -4. Zeros are at -1. Now we have to draw the root locus. The graph sheet take only one column on the right hand side, because root locus normally won't be on the right hand side. If it is there, you take. Otherwise, you can shift the y-axis not in the middle to the rightmost. Sigma j omega, S plane. So 0 is at -1, -1, 1, 0 is at -1. At -2, one pole is there. At -3, another pole. At -4, another pole. What is first rule says? How many root locus branches? 3 branches. 3 branches. Because 3 poles are there, open loop poles, therefore 3 branches. Second rule says, one root locus branch will end at 0, another 2 will end at infinity. Then third rule says, what is third rule? A point on the real axis. A point on the real axis, whether it is on the root locus or not. If you select any point between -1 and 0, is it on the root locus? Any point between 0 and -1, it is not on the root locus, because to its right, even number of poles and zeros. But if you select any point between -1 and any point between -1 and -2, it is part of root locus. Therefore, root locus starts at -2 and end at -1. Starts at -2, end at -1. Is there any root locus branch between -2 and -3? If you select a test point between -2 and -3, no, because to its right, even number of poles and zeros. But if you select any point between -3 and -4, odd number of poles and zeros, therefore it is part of root locus. 4 also starting point, 3 also starting point. Between these two at one point, repeated roots are there. Repeated roots are there. Repeated roots are there. Now we have to find the repeated roots. Therefore, what is n of s? N of s equal to what? N of s equal to s plus 1. What is d of s? D of s equal to s plus 2 multiplied by s plus 3 multiplied by s plus 4. What is that? S square plus 5s plus 6 multiplied by s plus 4. That is s cube plus 5s square plus 6s plus 4s square plus 20s plus 24. That is equal to s cube plus 9s square plus 26s plus 24. That is denominator. That is denominator. How to find repeated roots? Formula is d of s n dash of s minus n of s d dash of s equal to 0. Or you can write n of s d dash of s minus d of s n dash of s. Both are sign. Only minus sign. The problem. That's why what is d of s? D of s is s cube plus 9s square plus 26s plus 24. Check for any numerical mistake. Multiplied by n dash of s. If you differentiate that, you will get 1 minus derivative of d of s. What you will get? 3s square plus 18s plus 26 multiplied by s plus 1 equal to 0. Find the polynomial and find the roots. Find the polynomial and find the roots. Three s cube plus 18s square plus 20 3s cube 18s square plus 26s plus 3s square plus 18s plus 26 s equal to roots are s equal to minus 1.381 minus 3.61 minus 2.5. These are the three roots. Out of these three roots, which is the repeated roots? Out of three roots, how? At 1.381 minus 1.381 is here. Here, whether it is repeated root? No, it starts at minus 2 and ends at minus 1. It is not repeated roots. Minus 2.5 is here. It is not part of root locus. Minus 2.5 is not part of root locus. Minus 1.3 is no repeated root. It is not repeated root. But minus 3.61 is here. Therefore, minus 3.61, that is minus 3.61 is repeated roots, and it is breaking away like this. Breaking away at minus 3.61. We found the breakaway points. What is the angle of asymptote? How many asymptotes will be there? N minus m asymptotes will be there. Out of three root locus branches, one ended to 0. The remaining 2 goes to infinity, means only 2 asymptotes. What are the angles? Formula is phi a equal to plus or minus 2q plus 1 multiplied by 180 divided by 3 minus 1, that is equal to q equal to 0 comma 1, only 2 values. Q equal to 0 means what you will get? Divided by 2, 180 divided by 2, 90. One angle is 90, another one is 270. So, angles are this. What is sigma A? Angle of asymptote sigma A equal to sum of real parts of poles minus sum of real parts of zeros divided by n minus m, that is 2. Real parts of poles minus 3 plus minus 2 plus minus 4 minus 9 minus 9 minus 9 minus of minus plus 1 minus 9, sum of real parts of poles equal to minus 9, sigma A equal to minus 9 minus of minus 1 divided by 2, that is equal to minus 4. So the asymptote is at minus 4. asymptote is at minus 4. One asymptote goes upwards, another one goes downwards. Therefore, the root locus branch come closer to this minus 4 and goes to infinity like this. It goes to infinity like this. This is asymptote. This is asymptote. Asymptote. This is root locus. This is root locus. Root locus. It goes to infinity. Up to infinity it goes. This is go to j infinity. It goes up to j infinity. This goes to minus j infinity. Two asymptotes. One is at plus 90. Another one at minus 90. Or 270. That's all. So we used all the 6 rules and solved this sum. Already we have seen what is the angle of departure. Here it is required. Here at what angle it is coming out of 2j we have to find. At what angle it is coming out of minus 2j. At what angle it is coming out of minus 2j we have to find. That can be found by the rule 7. Angle of departure. The coming out of pole is called a departure. Arrival. If it is reaches 0, then it is called arrival, angle of arrival. Sometimes angle of arrival also required. For example, I am having two complex pole and complex 0. Here I have complex pole and a complex 0. Complex 0. These two are complex zeros. Two poles and two zeros. What will happen? This will come out and join here. This will come out and join here. At what angle it come out? We have to find. At what angle it come out? We have to find. At what angle it reaches? At what angle it reaches the 0? This is called angle of arrival. This is called angle of arrival. This is called angle of departure. Angle of departure. Angle of departure. We have to find both. We have to find both. Now let us find the angle of departure. Suppose I am having how many poles are there? 4 poles are there. 1 0 is there. 2 more poles are there. 2 more poles are there. 7 poles, 6 poles. 6 poles and 1 0. For that, I have to draw the root locus. All the open loop poles are starting points. These are all starting points. This is pole 1, pole 2, pole 3, pole 4, pole 5, and pole 6. All are starting points. What is the end point? This Z1 is the end point. Only one end point. So, out of 6 starting points, only one end at 0, the remaining 5 will go to infinity. Remaining 5 will go to infinity. Remaining 5 will go to infinity. But here, 2 complex poles are there. At P5 and P6, there will be angle of departure. Angle of complex pole is there means angle of departure. From P5, whether the pole is coming out from P5, it is coming out like this, or like this, or like this, we do not know. At what angle it is coming out, we do not know. From P5. From P5, we have to find. How to find? How to find? Suppose, let us assume that this is, I am selecting closest point, one point, yes. 1, I am selecting S0, very close to P5. Here I am drawing little bit away, but I am selecting very close to P5. If I join, suppose S0 is on the root locus, means the line of joining S0 and P5 is the angle of departure. Am I correct or not? Because S0 is very close to S5. If I draw line joining S0 and P5 is the angle of departure. Am I correct or not? Because S0 is very close and S0 is on the root locus. S0 is on the root locus. So, if S0 is on the root locus, means we have to find the angles with P1, that is theta 1, with P2, theta 2, with P3, theta 3, with P4, theta 4, with P6, theta 6, theta 6. This angle is theta 5. Am I correct or not? The angle of departure from P5 is theta 6. We have to find theta 6. We do not know what angle it is coming out. Theta 6 we have to find. If you join the line P5 and S0, that is the angle of, that is the angle. It is coming like this, means the angle is, this is the angle. That is theta 5. Theta 5 we have to find. We know that S0 is on the root locus. Therefore, if you add all these angle, it must be equal to what? 180. 2q plus 1 multiplied by 180. Therefore, I am writing theta 1 plus theta 2. I would put minus because theta 1. And for Z1 also an angle. That is theta 7, let us call. Or theta Z, let us call. One more angle is theta Z. So, minus theta 1, minus theta 2. Why I put minus theta? Because for poles, theta 1, theta 2, theta 3 are for poles. Minus theta 3, minus theta 4, minus theta 5, minus theta 6, and minus theta Z equal to plus or minus 2q plus 1 multiplied by 180. Am I correct or not? If you add all angles, I would put plus because it is for numerator. Theta 1 may be minus 70. Theta 1 may be minus 70. But why we are putting this minus sign? Because for denominator. Minus theta 1. Theta 1 may be minus 70. So minus or minus it becomes plus. Why I put minus 1? Because these angle for denominator polynomial. Theta 1, theta 2, theta 3 up to theta 6, it is for denominator polynomial, that's why minus. Theta Z is for numerator, that's why plus. If you add all this, that must be equal to 2q plus 1 plus 180, plus 1 multiplied by 180. Let us, what is required? Theta 5 is required. Theta 5 equal to minus theta 5 equal to plus or minus 2q plus 1 multiplied by 180 plus theta 1 plus minus theta 1 or minus of minus theta 1 minus theta 2 minus theta 3 minus theta 4 minus theta 6 minus plus theta Z. Except theta 5, I brought all to the right hand side because I have to find theta 5. I have to find theta 5. So if I know theta 1, theta 2, theta 3, theta 4, theta 6 and theta Z, theta Z, then I can find theta 5. Am I correct or not? If I know all these angles, theta 1, theta 2, theta 3, what is theta 1? Line joining S0 and P1. What is theta 2? Line joining S0 and P2. What is theta 3? Line joining S0 and P3. Theta 4, line joining S0 and P4. What is theta 6? Line joining S0 and P6. If I know these angles, I can find theta 5. But I do not know these angles. But I know that S0 and P5 are very, very close. Very close. Very, very close. That's why if I find the angle from P5 to P1 and the angle from S0 to P1 are same. Can I say like that? Theta 1 is equal to, listen here, theta 1 is equal to line angle made by line joining P5 and P1 or line joining S0 and P1. Can I say like that? Because S0 and P5 are very close to each other. S0 and P5 are very close to each other. That's why angle made by P1 and P5 and angle made by P1 and S0 are same. That's why I can say that theta 1, theta 2, theta 3, theta 4, theta 6 and theta Z are angle made by line joining P5 to all other poles and zeros. Lines joining P5 and all other poles and zeros. That is called the net angle contributed by line joining P5 and all other poles and zeros. What is the angle in question? Angle of departure from P5. Angle of departure from P5. Therefore, I am finding net angle by joining P5 and all other poles and zeros. That is P5 and P1, P5 and P2, P5 and P3, P5 and P4, P5 and P6, P5 and Z1 are connected. We are finding an angle that, assuming that that is equal to line joining S0 and all the poles. So, therefore, plus or minus 2q plus 1 multiplied by 180, this minus 5 net. Phi net, I am calling that angle equal to phi net. What is phi net? Phi net is angle made by lines joining P5 and all other poles and zeros. Angles made by lines joining P5 and all other poles and zeros. That's all. So I can find theta phi simply by finding phi net. What is phi net? Phi net is angle contributed by lines joining P5 and all other poles and zeros. That's all. That's all. Similarly, you can find theta 6. Normally, it is mirror image. Already we have seen. Rule number says 1. It is symmetrical about. Therefore, for P5, it is coming out at an angle minus 60 means for P6 it will be plus 60. Suppose from P5, this is P5, this is P6. Suppose this is coming out at minus 60 means it should be plus 60. Why we have to find P6? No need. If it is minus 60 means for this plus 60. So it is coming out at an angle like this. Here it is coming out at this angle. So we have to find that. We can find that angle minus theta phi equal to plus or minus, or you can write theta 5 equal to plus or minus 2q plus 1 multiplied by 180 plus phi net. So theta phi equal to plus or minus 2q plus 1 multiplied by 180 plus phi net. So how to find theta 6? You would put, instead of plus, you would put minus. That's all. Instead of plus, you would put minus. Or after finding that, negate that, you will get the angle. Because it is symmetrical about real axis. It is symmetrical about real axis. That's all. That is the angle of departure. The same way you can find the angle of arrival. For that angle, suppose angle of arrival means instead of plus, it will be minus. Instead of plus, it will be phi net will be here added. There you have to subtract. That's all. What is phi net? Phi net is line joining the pole or zero under question. Pole or zero under question to all other poles and zeros. Lines, angle made by lines joining the pole under question to all other poles and zeros. Do you understand that? What is theta phi? Angle of departure from P5. So this is the formula. Phi P, I am calling it as phi 5 because for fifth pole we found. Generally we can call it as phi P, or you can call it as phi Z. If it is from angle of arrival means phi Z. For phi Z it is minus. For pole it is plus. That's all. That is the only difference. Sketch the root locus for a system. I will give idea, you solve yourself. Sketch the root locus for the system with open loop transfer function. What are the poles? Poles equal to S1 comma S2 equal to minus B plus or minus square root of B square 16 minus 4 AC 52. Equal to how much? What are the poles and zeros? Minus 2, 3J. Okay, J3. Okay. Minus 2 plus or minus J3. The poles are at. So one pole at minus 2. This is, minus 1, minus 2, minus 3. Here j plus j plus 2j plus 3j minus j minus 2j minus 3j. 0 is at z equal to minus 1. 0 is at minus 1. Poles are at one pole is here, another pole is here. Therefore, angle of departure you have to find. How to find angle of departure? Line joining this and this you have to find. What is this angle? It is obvious. 90 degree. This is 90 degree. What is this angle? This angle. Here what is this? What is this? Minus 2 plus or minus plus j3. Am I correct? Minus 2 plus j3. Use calci. You follow what I am saying. Minus 2 plus j3 minus 1 equal to what? Minus of minus 1. Minus of minus 1 equal to what? Subtract from this P2. This is P1. This is P1. Subtract this P2 minus Z1 equal to what? Subtract. You will get minus 2 plus 1 plus j3. That is minus 1 plus j3. Am I correct or not? What is the distance between these two? You have to subtract from this point from this point. This is minus 1, this is minus 2 plus j3. If you subtract that, what you will get? Minus 1 plus j3. Am I correct or not? So, call the function polar to rectangle. Call P. Minus 1 comma 3. Enter minus 1 comma 3. Press equal to. Polar to rectangle function. 3.16 magnitude. Find the angle. 108.4. You can directly find that angle. 108.4 degree. I understand this. Test point minus other pole. Test point minus other pole. Then enter in polar to rectangular coordinate. You will get the angle immediately. You will get the angle immediately. You can enter 108.4. This is 90. So this is minus 108 minus 90. This is plus 1 because from 0. That's why plus. This is minus. What is the net angle? Phi net equal to minus 90 plus 108. This is plus 90 only. Why I put minus 90? Because denominator. So equal to what? 108.4 minus 90 equal to what? 18.4. Therefore, angle of departure from P2 equal to plus or minus 2q plus 1 multiplied by 180 plus 18.4 degree.